Today our topic is to learn about thermal physics. In this topic, we are going to discuss about thermal conduction. What happens when thermal energy is given to an object? We know that if a substance remains in low temperature, the particle movement becomes remote. That means these particles are not moving in a broader area. And the other one is the particles are close to each other. You can see there is a lesser space between these particles. All of them get together close to each other and their motion become much remoted at low temperatures. What happens when thermal energy is given to an object? You can understand that when thermal energy is given, the atoms gain more energy. As a result, we can see the atoms gain broad movement. Means you can see at the low temperature, here the movement is very narrower. They do not move much, but with the temperature increases, we can understand that their movement become much wider. With the meantime, we can see the gap between these atoms become much broader. So they like to be more wider when the temperature become higher. This is same as when what happened in our classroom. So you know that if it is a very cold weather, most of us do not like to stay apart from each other. But if it is a hot day, we know that we do not like to make them much closer. As a result, we're trying to be separated. The same behavior we can see in these microsubstances. When the temperature become higher, they try to be much apart from each other. And their activity also much broader. How does this happen? That's the main thing we have to understand. What is the behavior of these atomic substances if you given thermal energy into that? So from this Sankey diagram, we can understand that if you give thermal energy to a substance, what happens? When we provide thermal energy to a substance, the part of this energy converts into kinetic energy of the particles. Some part of the thermal energy converts into the kinetic energy of the particle. From this Sankey diagram, we can understand that the main part of the energy converts into the kinetic energy of atoms and rest into the molecular energy of the particles. So since this kinetic energy is broader, you can say the atoms get much broader movement, just like this. And as well as because of this higher gain of this kinetic energy, the atom try to be separated from each other at which tends to a expansion of this substance. Later on, we will discuss about this expansion. Right. Why does object expands with heat? That's the main fact we to understand. So if you consider the two atoms, they were at some sort kind of a separation, and there is some kind of a attraction between them. We know that there is an attraction between the molecules in a substance, right? When we provide heat and small portion of it absorbed as internal energy of the molecules. That means when you provide thermal energy, the small portion, not the main portion. So you can say from here even we can understand that the small portion is absorbed as the internal molecular energy, right? The molecules, right? Then you can say when you get a more what we call energy between these two atoms, then this bond become much stronger, right? The major portion absorbs as kinetic energy. As a result, molecular tends to separate further. Why does it happen? So you can say, if you get more kinetic energy, these atoms are much active. But in that case, since these atoms are more active, this atomic structure, this atomic bond cannot withstand as it is. As a result, they tends to much separated than before. That is why we observe an expansion with the temperature. If you simply say, if you provide thermal energy, the main portion of energy converts into kinetic energy. Therefore, this activity of these atoms become much broader. As a result, the atoms cannot they cannot stay at the same space as before, and they tends to separate it. As a result, we can see atoms or the substance get expand with the temperature. Right. The next concept we have to understand is what happened to density with temperature. That is the other important point. So in our previous slide, we have mentioned when we heat an object, it tends to expand. So if you get from this diagram, you can say, as a result, the number of molecules per unit volume reduces. So you can say, if this, the material or this object get expand, you can see on the same area I just mark over here. In this diagram, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, approximately 9 atoms in this area. But when it get expand, then it has turned up into 4 atoms. Now what happened? The mass per unit volume become lower. As a result, what happened? The density of the object reduces with temperature. So you can say, if you heat up object, it tends to expand. As a result, density become lower. But remember children, there are exceptional situations than this. So we will learn this in our advanced physics concept. For the moment, you have to understand, if you heat up, the density of the object reduces. Right. Then we are entering to the main part of this thermal energy. That is the way of transferring thermal energy from one place to another. There are 3 main ways where we can understand. The first way is the conduction. The second way is convection. Third way is radiation. So when you're concerned about this conduction, we can see the conduction occurs mainly in solids and convection mainly occurs in fluids. What do you mean by fluids? Fluids means liquids and gases. And radiation, there is no such preference to become solid, liquid or gas or anyway, whatever. Anyway, the radiation can occur in any kind of medium. No, actually there's a different concept of radiation. We will learn this radiation bit later. For the moment, we will try to understand the main topic in this video, that is conduction. Later on, I'll come up with radiation and I'll try to explain you what do you mean by radiation and what are the requirements and how does this radiation occurs. Right. If you come up with thermal conduction, right. Thermal conduction is the transfer of thermal energy or heat through the vibration of particles. Right. So this happened due to vibration. That is why mainly this occurs in solid. When you concern about fluids, sometimes the atoms are not much closer in fluids. But in solids, atoms are packed into each other. As a result, the vibration of atoms can be easily transferred into next level of atoms. Then the conduction is much efficient in solid substances compared with fluids, right? We know that in lower temperature, the atoms or molecules in a substance experiences a mild motion. They were just limited. The motion is just limited and they were just vibrating over here. When we heat them, the motion become more kinetic. Means you can see over here, when you heat up, this motion has more rapidness compared with this diagram. Here the motion is kind of limited, but here the motion is kind of much kinetic compared with this, right? Then, when we heat an object, the atoms or molecules in that corner become more kinetic. Here, if you go back to the initial condition, initially it's not kinetic. Now you can see here it's become much kinetic and tends to vibrate with higher amplitude. You see at the beginning, if you go back to the video over here, you can see we become much vigorous and much kinetic when you heat up this, right? When they collide with neighbor atoms, so when they try to move much faster, they try to collide with the next level of atoms. Then again, this transfers to the next level. Here you can see it's come up to the next level. Again, it come up to the next level and it transfers to this end, right? When they collide with neighbor atoms, the energy transfers and the vibration tends to leak onto them. So you can say, if you go back to the initial condition now, you can see at the beginning, here you can see it's now it tends to move. Like look at this here. This vibration goes to next level and at that one, so it come up to this corner. So the temperature from this corner transfer to this one with the transferring of this vibration. Here you can see now the vibration goes over here and it come over here and it's here, here. Now it come up to this corner, right? This process is called the thermal conduction, right? Then, in this slide, we are going to discuss the effect of delocalized electrons for the efficiency of thermal conduction. So, we know that these delocalized electrons also can bring this vibration or the thermal energy from one level to a next level of atoms. So, if you gain more delocalized electrons, what you can see, this thermal conduction become much effective and much efficient. So, you know that if you get more delocalized electrons, you can observe this thermal conduction much faster than the usual conditions. Right. Then, the thermal conductors and thermal insulators. What do you mean by thermal conductors? We know that thermal conductors are the materials which perform the thermal conductance efficiently. So you can say in thermal conductors, the transfer of thermal energy is much efficient. Here you can see it go much faster, go much faster. The thermal insulators are the materials which perform the thermal conductance inefficiently. So here it transfers but very slowly. It's not much efficient. That is what you need to understand about thermal conductors and thermal insulators. Right. Then what are the facts effective for this thermal conductance? The first fact is the atomic radius. Then we know that if the atoms are much radii, means the radius is wider, so from a small motion of this atom can be easily collide with the next level of atom. Just like if there are two fat people in a close to each other, the small movement is sufficient enough him to collide with the next person. Same way, if the atomic radius is wider, so the small vibration even can transfer the energy into the neighbor atoms. That is why the atoms with higher radii perform thermal conductance much efficiently. Then the next one is number of delocalized electrons. I told you the previous slide, delocalized electrons perform a major responsibility of thermal conductance. That means if you have more number of delocalized electrons, what happens? They can easily transfer the thermal energy from one level of atoms to next level of atoms. As a result, more delocalized electrons conducts thermal energy easier and faster. Right. Why different materials perform different thermal conductance? We know that all the materials are thermal conductors and they are very good thermal conductors, but the different materials perform different level of thermal conductance. What might be the reason? Then we know that if you get the periodic table and if you analyze about the atoms, different atoms have different atomic radius. Then in our previous slides, we already discussed the atomic radius is a one factor of performing the thermal conductance. If the atomic radius is wider, they perform the thermal conductance much faster and efficient. Therefore, the metals with higher atomic radii perform thermal conductance much efficiently. The other one is the number of delocalized electrons also change from atom to atom. So in that case, the atoms with higher number of delocalized electrons can perform thermal conductance much efficiently, right? Then how do you demonstrate this experiment as an experiment, right? This is pretty simple. We will take few rods with with same radius and same length, because I want to make the other fact effective for the thermal conductance unique. We need to see whether how does it vary from medium to medium. Therefore, we will take few rods with same length and same radius, but in different material. For example, aluminium, gold, silver, platinum, ferrous, etc. Right. Then we will place few wax on one corner of the rod from the same amount. Remember that when you place it, you have to put the same amount, right? Then what you're supposed to do is then we will adjoin the unwaxed corner and we will heat it up. If you heat up and we will observe the sequence that wax tends to melt up. So instead of wax, if you are unable to find some wax, you can use some pieces of butters or somewhere like that. We can use it something which is easily melt with temperature. Then we will see from which sequence it tends to melt. So the material where you can observe the melting rate is faster would be the material with the higher thermal conductance, and so on. You can understand with it. From a next video I will show you how to show it in our live classroom.
With this experiment, we're going to specifically look at conduction, but through different types of metal. While metal is generally a very good conductor, different metals will conduct heat energy at a different rate. We have 5 different types of metal. We have silver, brass, aluminum, stainless steel, and copper. At the end of each one is just a little pat of butter. We're going to light the candle underneath here. The heat through radiation and convection will rise, hit the center, and conduct out through each spoke. So we can see which type of metal will conduct heat the best. So we'll light the candle and start the timer. Let's see. So as you can see, we're well past the 12-minute mark here, and stainless steel is still holding on. It has not melted, it has not conducted enough heat energy along that stainless steel rod in order to melt that butter at the end. You saw right off the bat that aluminum and copper melted within the first minute or so, followed by brass and then silver. So those are all 4 of those are very close within the first 2 minutes. And here we have stainless steel still holding on there. So obviously, if you wanted to build something that would conduct heat quite well, aluminum or copper are great choices. You have some other factors involved there, including cost and how much of each of these metals are worth. If you wanted to build something that would resist heat transfer when it had to be out of metal, clearly stainless steel would be your choice.